Okay, so we're going to be starting on page 4 of our notes. This is the second set of 6.1. So we started talking about some of our rational exponents yesterday, but we talked about them as a 1 over n. Well, we can also write them as 3/2 or -1/2, so we're not limited to just saying 1 over n here. There are some properties we need to know before we can move forward with the rest of our lessons. When we have a to the m over n, well, we can rewrite this. We can split that fraction up. We can say, well, I have that 1 over n, and then I have the m power out here. Remember, 1 over n, that's the same thing over here. We can write that with a radical. It's the nth root of a, and then it's to the m power. Now, when we have a negative, I've highlighted it here for you to see. What we need to do is we need to make it positive and write it as 1 over a to the m over n. So we take it and we put it on the bottom and make that value positive now at the top. From there, we can rewrite it just like we did up above, a to the 1 over n to the nth power, and then the nth root of a to the m. We did this in a couple class periods on Friday. The main thing I saw that people were struggling with was rewriting these was when I had that a to the m over n, we were trying to say, okay, well, this is a to the 1 over n to the m. We were able to do that step, but then we would try and write the 1/nth root of a to the n. Remember, that is not what you're doing. This needs to be just n. So if we look at our examples down below, we have 16 to the 3/2. Well, if I'm going to write it in a rational exponent form, that means I only have exponents, no square roots, radicals, anything like that. So we would have 16 to the 1/2 cubed. Well, now I can write that 1/2 as a radical. It's going to be the square root of 16, and technically we have that 2 here. Notice how I didn't write a 1/2. I took whatever value I see on the bottom, and I wrote it here. Now parentheses, and it's cubed. Now for b, remember we need to do 1 over whatever we're doing. Well, we have the 3/5 on the exponent here. So my n in this case is 5, and my m is 3. So if I'm going to rewrite it in this form here, we have a 32 to the 1/5, parentheses, and then all of that is cubed. If we want to write that in our radical form, we're going to have a radical in it. So 1 over, we're going to have our radical. 32 goes on the inside. Well, our n was 5, so 5 goes here. Parentheses, and this is all cubed. So double check that you didn't write a 1/5 here, you wrote a 5. There are 3 practice problems down below. Go ahead and complete those now. Okay. So, for this next example, example 3, we're going to go through and fill in this chart, and now we're going to learn how to do this on your calculator. So if you don't have a calculator yet, go ahead and pause this and get your calculator. We need to rewrite this in 3 different ways. We want to make sure we have our exponent form, our radical form, and then we want a decimal approximation for each of these things. So we're just going to do this first column first. I have a 9 to the 1/5 power. Well, if I want to write that as a radical, we have the square root here, 9 goes underneath, but now we have a 5th. So with our 5th root here of 9, well, we know the square root of 9 is 3, but 5th root is not very nice. So what we need to do is on our calculators, we need to go ahead and type this in. Well, what we can do is if we click Control and then our caret button. So here, it will come up and it will allow me to type in what root I want to take with the number. So I can type 5 now and over to 32. Or sorry, 9. 9, that was the last problem, 9. When we do that, we'll get a decimal out, a 1.552. So if you look over here, the buttons I'm using here is the control, and then we want to use this function up above here. So it allows me to do the nth root of x. Okay, so now we're going to look at example B. We have 12 to the 3/8. Well, 8, that's on the bottom, that's going to become a part of our radical for our radical form here. 8 square root. Well, now we have the 12 underneath, and this is all to the 3rd power. So double check you're taking the denominator of your fraction, using that for your root, and your exponent on top is your exponent over here. Now, typing this in our calculators, once again we're going to click Control, like it shows over here, and then we want that function above the caret, so we'll click this button here. It will show up. We are doing the 8th root, so we'll click 8, type our 12 in, go outside of it. Well, now we also want this to the 3rd power. Well, if you click your little caret, that's how you type in your exponents, it'll automatically fill those parentheses in for you. You click the 3, enter, is going to come up with our answer. We find a 2.539 here. Remember, in Algebra 2, you always want to make sure you're using at least 3 decimal places. Now, if you don't like having to go in and type the nth root in, another way you can do this is just saying, okay, well, 12 to the, and you can just type in that 3/8 power, 3 divided by 8, click enter, and you'll get the same thing, 2.539. Now, for c, we need to take this, it's in its radical form, and we want to write it in that rational exponent form. So if this 4 is in here, working with my radical, that means it's the denominator of my fraction. So we have 7 to the 3/4 here. Well, now if I want to find this on my calculator, we're going to go ahead, I'm going to write it in the radical form still, 4 to 7, and then this is to the 3rd power. We'll get out a 4.304. If you prefer to type in the fractions, that is perfectly fine as well. Okay. There are some practice questions here. Make sure to complete those. Those will be due when you guys come back from the trip. Now, we can use these to solve as well. So that's the next big thing we're going to be learning here. In order to solve these, you need to make sure you get them into this form. U to the nth power equals d. Now our u could be another function. It's just saying whatever is raised to your exponent needs to be by itself. So if we look at our examples down below, well, x is to the 5th power. That doesn't affect the 4, so I need to get rid of that 4 because our u in this case is that x. So if I rewrite this here, 4x to the 5th equals 128. Well, I need to divide by 4 first. When I divide by 4, we're going to go ahead and get out a 32. So we have x to the 5th equals 32. Now, in order to solve this, I have x to the 5th power right now. Well, that means I need a 5th root in order to get rid of it. So we'll take the 5th root on both sides. So here we have x, and we have the 5th root of 32. So that's a 2. Now for b, we have x minus 3, and that has parentheses around it, and it's to the 4th power equals 21. What we're going to do here, well, our u in this case would be that x minus 3 because all of that is raised to the 4th power. So what we need to do here is you can't do anything with that 3 yet. This is where you will take that 4th root. So we have our x minus 3 on the left side now, and that's it, equals the 4th root of 21. Well, that's not a nice one. We need to go to our calculators here. So if I want the 4th root, 4th root of 21, that's going to be a 2.14. I'm just going to go ahead and use 0.7 because I still need to add and subtract things to it. So I'm going to add that 3 to both sides. But one thing we need to consider with this is I have the positive right now. So we can find our answer here. Well, if I add 3, we should just be at a 5.1407. This is one of our solutions. But remember, when I have something to an even power, we get out a positive, but we also get out a negative. So we also equal a negative 2.1407. So now when I added that 3 over here, I also need to add 3 to this, and we'll have our second answer. Well, if I have 3 plus a negative 2.1407, that gets us a 0.859. Okay, so flip your pages over. There are 4 practice problems on this side. Make sure to complete those. This is on page 6 of your notes. We're going to do one more problem. This is a real-life application problem. So it says, a hospital purchases an ultrasound machine for $50,000. So that's the first number they give us, so I'm going to go ahead and highlight that. That is what they purchased it for. Now, they're expecting it to only work for about 10 years for them. And after that amount of time, it'll depreciate to $8,000. So they give me a new value for it. And then the hospital uses the declining balance method for depreciation. And that's going to be this equation right here. Now, it tells me what each of those things in the formula means. It says, well, N is the useful life of the item. Well, it told us that the useful life of the machine would be 10 years. So we know N is 10 here. Well, next it says S is the salvage value. So if you get stuck here and you're like, I don't really know what a salvage value is yet. I don't know if that's going to be my 50,000 or my 8,000. Not really sure which. Go ahead and skip it and say like, okay, well, do I know what C is? Because process of elimination. Well, C, that's the original cost. Well, it cost them $5,000 to purchase it. So S, salvage, must be the depreciated cost at $8,000. So what we're going to do here is R is now equal to 1 minus 8,000 divided by 50,000. And this is all to the 1 over n, so to the 1/10th power. So from here, you'll type that into your calculators. So on your calculator, you'll have 1 minus, you'll have an 8,000 divided by a 50,000, and that's all to the 1/10th power. So R in this case, 0.167, and it tells us, okay, it gives you this in decimal form, so it's this, or a 16.7%. Now, there's a practice problem down below. Go ahead and attempt that now.